In this video, we will see how to graph a quadratic equation by transforming it to its standard form to identify the vertex and the y-intercept. That way, we will be able to draw a sketch of its graph. Let's start with our first example. We are going to graph the equation 3x squared plus 6x plus 4 by rearranging it so it's written in its standard form. When we write the function in its standard form, it has to look like this. Y equals a times x minus h squared plus k, where h and k represents the coordinates of the vertex, and the sign of a will tell us the orientation of the parabola. If a is positive, our parabola will be opening upward, and if a is negative, our parabola will be opening downward. To begin, we see that we have first a constant and a squared binomial. We are going to start by separating my first two terms with the variables inside a parenthesis. And instead of writing f of x, I will write y. Y equals 3x squared plus 6x, close the parenthesis, plus 4. Now, it's still not like the standard form because I need a squared binomial. And also, I notice in the formula that the x doesn't have a coefficient. The coefficient a is outside the parenthesis. So I need to factor out number 3. So y equals, now I factor out number 3 and divide the binomial over 3. So 3 times what gives us 3x squared? X squared. 3 times what gives us plus 6x? Well, 2x. And then plus 4. Okay, to double check if I did the division correctly, I can multiply 3 times the binomial and check that I get what I had originally. So 3 times x squared, 3x squared, and 3 times 2x, 6x. We are correct. So we can continue. Now, I still don't have the standard form of the equation because I need my binomial to be squared. So the 2 has to be outside the parenthesis. And it's not yet. I need to remember that when I have a binomial, a squared binomial, like a plus b squared, the result is a perfect square trinomial. A squared plus 2ab plus b squared. Therefore, in order to get a square binomial by factoring, first I need to have a perfect squared trinomial. And I don't have it yet. I only have a binomial. So in the next step, I'm going to complete the trinomial. Y equals 3 times x squared plus 2x. Here is where I'm going to add the missing third term, plus 4. To find the third term of the perfect square trinomial, I need to check the second term of the binomial, take half, in this case is 1, and then square that answer. In this case, since it's 1, 1 times 1 is 1. So I'm going to add 1 to the binomial, so I now have a perfect squared trinomial. Notice that number 1 is inside a parenthesis, and the parenthesis is being multiplied times 3. So by writing a number 1 inside the parenthesis, that number 1 is being multiplied times 3. So I actually just added 3, not 1, because 1 times 3 is 3. And remember that in equations, you can't just randomly add a number, because by adding this number, it's no longer the same thing as the function that I had originally. So I need to balance the equation. And to do that, since I just added 3, I need now to subtract 3 to keep the same value that I have. So be careful to check if you have a coefficient. If you have a coefficient outside, like this number 3, whichever number that you add here is going to be multiplied times 3. And you're going to have to multiply it to then subtract it. If you don't have a coefficient, you would have only to subtract the same number that you wrote inside the parenthesis. Okay, so now that we have our perfect squared trinomial, let's continue. Y equals 3 times. Now that we already have a perfect square trinomial, we can factor it to get our squared binomial. To do that, we are going to use the square root of the first term, the sine of the second term, and the square root of the third term. So, square root of x squared, x, sine of the second term, plus square root of the third term, square root of 1, 1. Okay, so that's our binomial we are going to square. And now we answer the addition or subtraction that we're going to have at the end. 4 minus 3, 1. Now we can easily identify the vertex of this parabola with the values of h and k. The second number in the parentheses would be h minus h, because that's what the formula says here. And the number outside would be k. That means that the vertex of this parabola is minus 1, comma, 1. Remember that since the number inside the parentheses is minus h, the value will always be the same number but with the opposite sign. We can now graph the vertex in our Cartesian plane. But now to sketch the parabola, first I notice that number 3 is positive. That means that my parabola is opening upward. But to know the width of the parabola, I look for the y-intercept. Remember that when you're looking for the y-intercept, it means that the value of x is 0, because you're looking for the value of where your parabola is crossing the y-axis. To find the y-intercept, just substitute 0 in your original equation. 3 times the square of 0 plus 6 times 0 plus 4. And since we are substituting 0, 0 squared is 0 and 6 times 0 is 0, it cancels out, and our result will always be the last number, in this case 4. So the y-intercept is 0, comma 4 here. Now remember that the parabolas are always symmetric, so the vertex is always exactly in the middle of the parabola. So since the y-intercept is 1 unit right and in 4, then to the other side is going to be 1 to the left, also in 4, because the vertex is over the axis of symmetry. And with these 3 points, we can now trace the sketch of our parabola, which it would look something like that. Let's solve a second example with less annotations. We now have the equation minus x plus 1 squared minus 3. But since this equation is already written in standard form, we only have to identify its key parts. We need the vertex. Remember that we get it by this number and that number. So the vertex is minus 1, comma, minus 3. Now the y-intercept, we are going to get it by substituting 0 in the value of x. So x is 0 and y is minus 0 plus 1 squared minus 3, which is 0 plus 1, 1. The square of 1, 1. Minus 1 minus 3 is minus 4. So 0, comma, minus 4. First, we graph the vertex in minus 1 and minus 3. We have it here, the vertex. Now, the value of a, in this case, we don't have a number. That means that it's 1, but it's negative. That means the parabola is going to open downward. Its y-intercept is 0, comma, minus 4. So 0, comma, minus 4. It's here. And since it's symmetric, we count 1 to the other side of the vertex, also in minus 4. And now we can sketch our parabola. Something like that. Let's see our last example. In this third example, we are going to graph the quadratic function x squared minus 2x plus 6. we rewrite the equation by separating the first two terms inside a parenthesis, the ones that have the variable. Y equals x squared minus 2x, close the parenthesis, plus 6. Now, we don't need to factor out a coefficient because the first term doesn't have a written coefficient because it's number 1. So we can go directly to completing the perfect square trinomial. Y equals x squared minus 2x. I leave space for my third term, plus 6. To get our third term, we take half of the second term, which is 1, then square that answer, and it's still number 1 in this case. So I add 1. Since the parenthesis is not being multiplied times anything, I just added number 1, so that's what I'm going to subtract. Subtract 1. Now that I have the perfect square trinomial, now I can factor it as a squared binomial. Remember the steps? Square root of the first term, x. Sine of the second term, negative. Square root of the third term, 1. These are the terms of the squared binomial. And then we solve 6 minus 1, 5. Now that we have our quadratic equation written in standard form, we can easily identify the vertex. It's 1, 5. And the y-intercept is x0, y6. Now we can graph. Vertex in 1, 5, which is here, and y-intercept in 0, 6. So 0, 6, which is here. And since the parabola is symmetric, and I know that it's opening upward because x is positive, so if to the left is 1 above, to the right 1 above as well, in 2, 6. Now we can trace the sketch of our parabola. Now you know how to sketch the graph of a parabola by identifying the vertex and the y-intercept. Thank you for watching this video.